they're in the XY plane or whether they're in 3 space. But they'll go back and forth in the book in chapter 12 with this. Sometimes it'll be in R2, sometimes it'll be in R3. It's easier for me, of course, to sketch something in R2. So I'm going to do a little example there. I'll call it that. Here's R2, and I'm going to put a vector in R2. Here's a vector. I will call this vector V. We're not real fancy on the names, but there's vector V. And what I can do is I could move vector V to different places on the grid, and it's the same vector. It has the same length, the same direction, it's the same vector. So what do we kind of like to do? Move it to where the initial point is at the origin. So there's my initial point, and I'm gonna I took vector V, and I don't want to run into vector V. Pretend they're perfectly parallel, all right? And I've moved vector V. I didn't give it much thought when I drew the first version of vector V. I moved vector V to where the initial point, or the tail, is at the origin. When I do that, we give that one a special name. What is it? Just checking to see if you may know from physics. That's the position vector. So a vector, positioned so that the tail is at the origin, is called a position vector. And in R2, I'd be talking about, of course, the point 0, 0. In R3, we're talking about the point 0, 0, 0. And here's an example. Sketch a vector whose initial point is at, so this is not a position vector, but I'm going to say the initial point is at the point 2, 5, and terminal point is at, maybe I'll call the first one point P, the second one point Q, and Q is -3, 2. So I want to sketch that vector, and then I want to also sketch the position vector. I want it same vector, but I want to put it where the initial point's at 0, 0. So let's see, I'm going to end up with this. P is 2, 5. So I'll just plot that point. Q is -3, 2. And so the vector be here. In fact, I would call that, let's put P, and that's vector Q. I would call this vector PQ, where the initial point is given first and the terminal point is given second. And if I wanted to use a single letter, vector V, vector W, something like that, I could also do that, but I'll just call this one vector PQ. Now I want to take vector PQ and move it so that the initial point is at 0, 0. A couple of ways you could do this. I could look at it and say, okay, P moved down 5 units and left 2 units. So Q is going to move down 5 units and left 2 units as well. So let's have 1, 2, 3, 4. Here's -3. And then over 1, 2, 3 is -5. So Q would move to here. And then here's my same vector, but the position vector for it. How else could I have just done that? I could have said vector PQ. By the way, I need to mention some other notation that students in the past have said they didn't see this notation in physics, but you'll see this in the calculus book. For a vector, we'll give the components in angle brackets. So when you see those angle brackets in the book, it is a vector. And so vector PQ, isn't it this? 3 minus, I said it backwards. It's going to be tip minus tail, Q minus P, -3 minus 2, and then 2 minus 5. So vector PQ, this is the position vector for PQ, is -5, -3. And so what I can do when I see this is I know the initial point is at 0, 0, and the terminal point is at -5, -3, and I can sketch the vector in that manner.